Okay, so you remember that in grade 11 I taught you how to do bending moments. I just want to quickly recap it with you so you can remember how to do it. Now, remember that when we look at bending moments, imagine this is your beam. Now you have the force that's going up. Now if I press up on this ruler or this beam, it's not doing anything. And on this side as well. So that means there's no bending at the points. So the bending moments are 0. But where do I have forces that's going down? There. If you look at it closely, it's bending. And there, if I press, it's bending. Okay, so it will have a bending moment there and there. But your ends are going to have a 0 Newton meters bending point. Okay, so I'm going to add, let's say, C and, let me just get another color, and D as the two bending moments that we have to go and calculate. Okay, so we're going to start with bending moment C to calculate it. So please just take a piece of paper, or you can take your hand if you want to. I'm going to take the calculators back and I'm going to cover up where C is. Okay, because we're only going to look at the stuff on this side. Now remember, for bending moments, every force that goes up is going to be positive, and every force that goes down is going to be negative. Okay, it works a little bit differently to the reactions that we just worked out. So remember in the first example, we worked out A as 8 newtons and B as 7 newtons. But now we want to work out the bending moment points, so that's C and D. Now we close up C and we look on this side. Now the first force there is A. Now is A positive or negative? It's going up, so it's positive name. And how big is A? It's 8 newtons. How far is A from C? 1 meter. So I say times 1 meter and close the brackets. Okay, so this is the only force here. But if you look at C, there is a force that is at C, right? It's right on top of it. So the 9 newtons is going down, and down means it's negative. So because it's going down, pressing down on C, I'm going to say 9 newtons, and it's on top of C, so there's no distance, it's 0 times 0 meters. Okay, now 8 times 1 is 8, minus 9 times 0 is 0, because anything multiplied by 0 is 0. So that gives me my bending moment C is going to be 8 Newton meters, because newtons times meters. And that's it. There you have C. So now let's quickly look at D. So you close up everything after D and you write bending moment D. Alright, let's see. Now we start all the way this side again. A over there is going up. It's going up, so it's positive. It's 8 newtons. And how far is A from D? It is 2 meters. So times 2 meters. Okay, so we're done with this one. The next one is going down, and because it's going down, it's going to be negative. So minus 9 newtons. And how far is the 9 from D? Just 1 meter. So times 1 meter. Okay, so we're done with this one. And then the last one is on top of D, so it's the 6 newtons. It's also going down, so it's also going to be negative, minus 6 newtons. And how far is it from D? It's on top of it, so it's 0 times 0 meters. Okay, so 8 times 2 is 16 Newton meters, minus 9 times 1 is 9 Newton meters, and 6 times 0 is, anything times 0 is 0. And then 16 minus 9 is going to give me 7. So my bending moment at D is going to be 7 Newton meters. And that's it.